Imagine looking up at the sky and seeing brilliant, dancing lights of green, purple, and red illuminating the night. Sounds like magic, right? But this magic is real, and it's happening because of the sun. Today, we're diving into how solar storms can light up the sky with the breathtaking auroras, and how a geomagnetic storm tonight might let us see them from unexpected places like California and even parts of Europe. Ready to learn about this cosmic light show? Welcome, aurora enthusiasts! Today, we're exploring one of the most mesmerizing phenomena in the universe, the northern lights, or auroras, and the space weather that makes them possible. But did you know that these beautiful lights come from powerful storms? Yes, just like our planet has weather, space has its own kind of storms, and they're caused by none other than our very own sun. Space weather refers to the activity that happens between the sun and Earth, influencing our planet's magnetic field, atmosphere, and sometimes even our technology. When the sun releases bursts of energy and particles, it can cause what we call a geomagnetic storm. These storms are disturbances in Earth's magnetic field, and they can cause everything from electrical disruptions to one of nature's greatest displays, the auroras. It all starts with the sun. Occasionally, the sun has massive explosions called solar flares and releases vast amounts of plasma in what we call coronal mass ejections, CMEs. These energetic particles travel through space, and if they're aimed at Earth, they collide with our planet's magnetic field. When this happens, it creates disturbances, or storms, in the magnetic field, which then produce the dazzling northern and southern lights. While these storms might sound threatening, their most visible impact to us is often the creation of auroras, glowing, dancing lights that grace the night sky in shades of green, purple, red, and blue. Normally, they are visible closer to the poles, but during more powerful storms, they can be seen much farther south, potentially even from where you live. We have an exciting event on the horizon. The National Oceanic and Atmospheric Administration, NOAA, has issued a G3 level geomagnetic storm warning for today. This means that the chances of seeing the auroras have increased significantly, even in places as far south as Missouri and California. This storm is classified as moderate but strong enough to create a spectacular light show. As always, I want to take a moment to thank all of you who support this channel. Now that we've set the stage for what geomagnetic storms are, let's dive deeper into the heart of the action, the sun itself. The sun, this massive ball of fiery plasma, constantly emits streams of particles called the solar wind. But occasionally, it erupts in much larger, more intense events that lead directly to the formation of auroras. One of the key drivers behind these spectacular storms is what's known as a coronal mass ejection, or CME. Think of it like a giant bubble of solar wind and magnetic fields that burst from the sun's surface during massive eruptions. These ejections can hurl billions of tons of solar material into space at extremely high speeds. If one of these CMEs is aimed in Earth's direction, it can reach us in just a few days. When the CME collides with the Earth's magnetosphere, it's like throwing a rock into a pond, creating ripples. These ripples in the magnetic field can cause significant disturbances, leading to a geomagnetic storm. But where do these CMEs come from? Often, they are linked to intense solar flares. Solar flares are sudden, powerful bursts of energy that occur when the sun's magnetic field lines snap and release energy. These flares can be classified by their intensity, with X-class flares being the most powerful. A recent X4.5 class solar flare on September 14, for example, helped propel a CME toward Earth, which is exactly why we are on alert for the geomagnetic storm tonight. During solar flares and CMEs, the sun releases highly energized particles, such as protons and electrons, which make their way to Earth and interact with our magnetic field. These charged particles are responsible for the vivid auroras that light up the skies. So how exactly do these particles create auroras? When the charged particles from the sun collide with the gases in our atmosphere, primarily oxygen and nitrogen, they transfer energy to these atoms. When the atoms return to their normal state, they release that energy in the form of light. This light can appear in various colors, with green and pink being the most common. The colors you see depend on the type of gas and the altitude where the collisions occur. For instance, Green auroras are produced when particles interact with oxygen at lower altitudes, up to 150 miles. Red auroras occur when oxygen is hit at higher altitudes, above 150 miles. Blue and purple auroras happen when nitrogen is involved. This process explains why auroras appear as curtains or ribbons of light in the night sky, shifting and shimmering as the particles continue to interact with Earth's atmosphere. The CME that erupted from the Sun 2 days ago is heading straight toward us, and when it reaches Earth's magnetosphere, it could create a light show visible far beyond the polar regions. Thanks to the power of this particular geomagnetic storm, people in unexpected locations like California, Oregon, and even parts of Europe may catch a glimpse of these beautiful lights tonight. Now that you know how auroras form, let's talk about the different types and where you can actually see them. There are two main types, aurora borealis, which happens in the northern hemisphere, and aurora australis, in the southern hemisphere. Both are caused by the same process, solar particles hitting Earth's atmosphere, but they show up in different parts of the world. The aurora borealis, also known as the northern lights, is the most well-known. It's usually seen in areas close to the North Pole, like Norway, Canada, Alaska, and parts of Russia. But during strong geomagnetic storms, like the one forecasted for tonight, these lights can appear much further south, in places like California, Missouri, and even parts of Europe. The aurora australis, or southern lights, happens in the southern hemisphere. It's usually visible from places like Antarctica, New Zealand, and the southern tip of South America. While it's less commonly seen than the northern lights, it's just as stunning when it does show up. So, where and when can you see them? Normally, the best places to catch auroras are near the poles, but during stronger storms like the one expected tonight, you might be able to see them in places much further away from the poles. In the US, keep an eye on the northern skies, especially if you're in states like Oregon, California, or Missouri. In Europe, you might catch a glimpse as well. The best time to look is usually around midnight or in the early morning hours. And if you're really serious about spotting them, there are some great apps that can help you track auroras in real time. Apps like My Aurora Forecast can alert you when the conditions are right for aurora activity in your area. While auroras are beautiful, geomagnetic storms can have effects that go far beyond the night sky. These storms can actually have a significant impact on modern life, and it's important to understand how they affect the Earth and the technology we rely on. One of the biggest concerns during a geomagnetic storm is how it can interfere with our technology. The charged particles from the sun can cause fluctuations in Earth's magnetic field, which can mess with everything from power grids to communication systems. In extreme cases, geomagnetic storms have knocked out power in entire cities, disrupted GPS systems, and even interfered with satellite operations. So, while we're watching the skies for auroras, scientists and engineers are also monitoring these storms closely to protect critical infrastructure. To give you an idea of how serious these storms can get, let's look at the most famous example, the Carrington event of 1859. This was the largest recorded geomagnetic storm, and it had a massive impact on the telegraph systems of the time. Some operators were even shocked by electrical surges, and the storm caused telegraph lines to spark and catch fire. If an event like that happened today, it could potentially cause widespread damage to our modern electrical and communication networks. More recently, a geomagnetic storm in 1989 caused a power outage that left 6 million people in Quebec, Canada, without electricity for several hours. These events show that while auroras are breathtaking, the storms behind them can have very real consequences. Thankfully, we've come a long way in understanding and preparing for geomagnetic storms. Agencies like NOAA and NASA are constantly monitoring the sun for signs of solar flares and CMEs, giving us advance warning of potential storms. With modern technology, we can predict when these storms are likely to hit and take steps to protect sensitive equipment, such as placing satellites in safe mode or adjusting power grid loads to avoid overloading. The storm expected tonight is classified as a G3, which is considered moderate but still strong enough to potentially cause some minor disruptions to satellite communications and power systems. However, it's unlikely to cause major issues. Scientists are watching closely to see how it unfolds. As we wrap up this deep dive into geomagnetic storms and auroras, it's important to look ahead. The field of space weather is advancing rapidly, and as our reliance on technology grows, so does the importance of predicting and understanding these solar events. But what does the future hold for space weather forecasting and our ability to witness auroras? Thanks to modern technology, we're getting better at predicting when solar storms will occur and how strong they'll be. Satellites like NASA's Solar and Heliospheric Observatory, SOHO, and NOAA's GOES satellites constantly monitor the Sun, providing valuable data that allows scientists to track solar activity. With this information, we can often predict when a coronal mass ejection, CME, will hit Earth, giving us some time to prepare. Artificial intelligence, AI, and machine learning are also playing a role in improving our space weather models. These tools can help scientists analyze vast amounts of data and make more accurate predictions about the intensity and timing of geomagnetic storms. As these systems become more sophisticated, it's likely we'll be able to predict auroras with even greater precision, giving aurora hunters more chances to plan and witness these magical light shows. As solar cycles ebb and flow, the intensity and frequency of auroras will vary. We're currently in solar cycle 25, and over the next few years, solar activity is expected to increase. This means more solar flares, more CMEs, and, you guessed it, more opportunities to see auroras, possibly even in areas where they're not usually visible. So, if you're fascinated by auroras and space weather, there's never been a better time to stay tuned in. With advancements in prediction technology and a more active sun on the horizon, we're in for more frequent cosmic light shows in the coming years. If the idea of witnessing more auroras and understanding the mysteries of space weather excites you, don't let this moment pass you by. Just like we track the solar winds to predict auroras, you can track our channel by hitting that subscribe button. This way, you'll always be in the loop whenever space weather is about to light up the skies, or when we dive into the next great cosmic mystery. Don't miss out, subscribe now, and be ready to witness the universe in action.